Grundig 3299 stereo, 1961. This is the documentation of the experience of a hobby project, available in video and in written form, made with the hope that it could be helpful to others. But any comment that could help me to improve my practice is welcome and appreciated. This is an early FM stereo receiver made at the beginning of the 1960s by Grundig. The cabinet takes the space of a horizontal rectangle, very likely thought to be combined with other squared audio components, considering that the radio requires external loudspeakers or amplifier. It seems that aesthetics have taken priority over electronics because the stereo power amplifier area tends to be very warm, but in a relatively small space. According to radiomuseum.org, this radio might have an asbestos sheet on the inner top of the cabinet. If you are considering buying or inheriting this radio, you should know that you might find such a thing, and you would bear the responsibility of disposing of it because leaving it in the cabinet would not be safe. Luckily, this particular unit under restoration arrived without such an uncomfortable and unsafe piece. The full story of this unit is not known, however there are traces of the accidents that occurred to it. The label of a servicing center, with a phone number made only of 5 digits, recalls mixed feelings with memories of a long time ago. The most conspicuous accident happened to the expenses of the dial glass. It must have been broken twice, the first time in correspondence with the left hole, the one used by the volume shaft, the second time near the other hole, the one of the tuning shaft. The dial glass is relatively thin, 3 millimeters, and quite wide beyond the width of the chassis. Either a false maneuver while servicing it, or a tension caused by a significant temperature variation might have been the reasonable cause of the double accident. The radio mounts a transformer that is not original, and the selenium rectifier bridge has been replaced with a more recent component. The chassis has diffused little traces of corrosion, probably due to the exposure of some acid vapors. The perforated panel that covers the big hole under the chassis was broken, probably just because of a normal pressure applied with one hand while moving the radio in different places. Being a stereo FM and AM radio receiver, its schematic diagram is fairly complex, and it is indispensable for proper servicing. What you see is the original schematic diagram with some extra annotations, but the video does not provide enough detail. The written documentation that is available in the links appearing in the description of this video under the Show More tab includes a better resolution schematic diagram and all the references to find the original published online. Online one may find also information regarding the dial cord arrangement and the alignment procedure. However, for this partial restoration project, no alignment is performed. Following the style that was preceding the usage of printed circuit boards, under the chassis the components are installed on layers. Luckily, the chassis is large enough, and there is still the possibility to reach most of them, even though the procedure is not so comfortable, and a full restoration is probably not advisable. At least the radio appears to be capable of working, already at the beginning after fixing an open connection with the power transformer. That is comforting. With patients, all the electrolytic and paper capacitors are replaced. In fact, testing the paper capacitors, they seem to have almost the double of their nominal capacity, which is a symptom of a significant internal electrical leakage. Where possible, in place of the paper capacitors, ceramic ones have been used for a better safety. However, one should keep in mind that ceramic capacitors shift their value with the variation of the temperature, and they might induce microphonic effects. So they would not be acceptable in high-frequency modules unless they are NP0 capacitors, and in units that could be subject to significant vibrations. The chassis is not treated to remove the traces of corrosion, but silicon oil is used everywhere, also to inhibit the development of rust. This radio has a particularly sophisticated dial mechanism. Tuning of FM and EM are distinguished by two different indicators controlled by the same shaft. The problem is that this mechanism relies on friction and spring pressure, while with time it could become loose, making the tuning impossible. A full restoration of this mechanism would require to dismantle the shaft with the friction system, replacing the frictions with some proper material and regulating the right pressure on them. An attempt to do this work without removing the shaft, but with some felt or with some other soft stuff, failed. The friction discs should be relatively hard, as removing and reinstalling the shaft would have implied a very delicate work, with the risk of doing more damage than repair. The usability was prioritized, and the two dial movements were joined using hot glue. Obviously, such a choice is not recommended. Whatever choice one makes in the presence of a similar mechanism, also the lever that pushes the pulleys to one side or to the other should be tuned properly or moved aside, like in this case. The Model 4198 has a similar mechanism, which is described thoroughly by M. Caldera in this video. The radio arrived with a broken dial glass. Reproducing the dial glass would be complicated, also due to the particular trapezoidal shape. In this case, a test was made with some black corrugated plastic sheet. The test was so satisfactory that initially a more normal dial glass was not rebuilt. Under the chassis, the cabinet of this radio has a big rectangular hole covered with a thin and densely perforated panel. That panel is very fragile, and applying just a little pressure would break it, with the hazard of getting in touch with high voltage connections under the chassis. This is also the story of the panel of this unit, although we hope that that did not happen when the radio was connected to the mains. Repairing the panel appears to be impractical, but also replacing it with a reproduction does not seem safe enough. Even though the perforated panel served the purpose of allowing the airflow, for safety concerns it is replaced with a fully closed panel. Also, this replacement is made of the same corrugated plastic sheet used for the dial glass. While trying to put the chassis back in the cabinet, it appeared that the switching keyboard and the small tone controls were not working correctly because they were not properly aligned nor spaced from the cabinet bottom. It has been necessary to put a spacer of 2 millimeters to tilt the chassis up using a couple of thick washers like in the way that is visible from these pictures. This radio is fully capable of functioning just with its internal antennas. The radio incorporates a ferrite antenna for medium wave and long wave and an aluminum sheet dipole attached to the internal surface of the cabinet used for the FM band and also for the short wave band. All bands are received fairly well with these internal antennas, including the short wave. This radio requires 2 external loudspeakers. For this purpose, something is built using 2 tuna cans and 2 small loudspeakers recovered from broken Bluetooth devices. Despite the cheap construction, they seem to work fairly well. Very soon the black plastic used in place of the original dial glass was not satisfactory anymore, and a plan was made for making a new decent one. An online service was used for getting a piece of acrylic glass cut with the right shape and holes. When it arrived, the dial scale was redrawn using Xfig, which is a very old but also very good piece of free software, and then the piece of acrylic glass was printed with the new drawing from a specialized printing service. In the written documentation that comes along with this video, there is a better detailed picture of this drawing. With the occasion of this revision, also an RF buffer is added with the purpose of making available the frequency of the local oscillator to an external frequency counter, but only for the AM bands. This is the schematic diagram and plan using a common general-purpose perforated board, and the following clips show all the process of building and installing it. The board is reduced to fit in the small box. The value of every component is verified before putting it on the board. When there are enough components on the board, a preliminary test is performed, and the result is comforting. There is still an electrolytic capacitor to install, which does not fit on the board. Then, it is time to prepare the holes on the small box. Because of the time during the night in which all this is done, instead of using a drill, the drill bits are used by hand. In this radio, the box is used especially to hold the BNC connector, but with the occasion, it will also contain the buffer board, hiding it nicely. Because the board will not be directly in contact with the chassis, more last-minute connections for the ground are added. All the wires are prepared, and then the board goes finally in its box. Before installing the box containing the RF buffer, it is noticed that this inductor is externally broken, although not open yet. Unfortunately, the schematic diagram does not report the inductance value that it should have. The inductor is removed and measured. The meter does not reach zero, therefore the value read with the original inductor is compared with the possible replacement. It seems that the original inductance should have been around 4.7 microhenries. The box containing the RF buffer is placed on the chassis and fixed with very short screws from under it. The RF buffer is powered by the AC filament voltage. The RF signal is collected from the plate of the converter mixer tube, corresponding to pin 8. The radio is still working fairly well, and it was not aligned during this restoration. The AMIF transformers are supposed to be aligned at 460 kHz according to the original documentation. Therefore, the frequency counter is configured for subtracting that frequency. However, checking the frequency of the known AM stations, it turns out that in this radio the AMIF transformers are aligned at 455 kHz. In fact, this way the local stations at 1170 and 549 kHz show up exactly at the expected frequency.
Prvič so iskane, cenjene in drugič izdelek, ki dosega ceno. 14-dnevno dogajanje se bo začelo to soboto z Antonovim koncertom pevskega društva Okarina. Prihodnjo sredo bo okrogla miza o priložnostih.
Maybe when this radio was serviced before, it was realigned for some reason, without knowing the correct value for the IF transformers. Anyhow, it works, and that is good. The radio is slowly put back together, starting from the new dull glass. It must be carefully aligned with the band selection and tone shaping keyboard. The Magic Eye tube is installed on the dial glass, and it must be centered in its vertical window. The knobs should have been put on before. They will be inserted on their shafts off camera. The chassis is held to the cabinet by 4 screws. Here the back panel is installed. However, to access the RF buffer, one has to connect a coaxial cable to the BNC on top of the small plastic box and let it come out from one of the existing openings on the panel. This cable will be connected later off camera. The radio is tested in the evening, beginning with the FM band and ending with the long wave band. For the FM, the radio is connected to the internal dipole antenna.
Azzaro per le padrone. Suo profumo, cascarci dentro. È come fare. Le gusta con la mía.
Shortwave. For all the M bands, it is possible to read the tuned frequency with the frequency counter, which was configured for subtracting the intermediate frequency value.
Pentru a ne asculta din Statele Unite, formați 716-274-2507. Pentru a asculta programele RRI în limba română,
Respect. Okay, back. Church, get off your high horse. Defend Islamic State, not being any worse than.
Puis la Turquie estime qu'un système démocratique, un gouvernement centralisé et des frontières protégées par une autorité unitaire est la seule solution. Il faut calculer une utilisation efficace de la diplomatie régionale. La Turquie coopère avec les pays arabes bilatéraux et multilatéraux pour la reconstruction politique et économique de la Syrie.
To stay there for 5 days for them to fix the roof and make sure that the building is safe again for them to live in.
L'approche people whose housing.
Esos temas, mi amigo y yo, unos más interesantes.
De Turquie dans la région.
When it comes to conversing with people, and I
800 évvel később ugyanekkor a hajóval kelt.
比所新一代高性能的超大型。There's most we're like, well, we're bigots, we think too much of ourselves. We are incapable of going into space above low Earth orbit because there's actually a passage from the Bible that is missing. Interpreted nel sviluppo. Spesso ha avuto origine dalle canzoni popolari, dalla musica popolare e da molti tipi di danze popolari che venivano improvvisate dagli esponenti di vari gruppi occidentali della Cina durante la loro vita produttiva nei tempi antichi. Il vocabolo finale è stato tra la gente già più di 1000 anni fa. Spesso ha ereditato la tradizione della musica e della danza delle regioni occidentali. 全球最大的汽车音响生产基地，比西里是。至少畅销全球，特别是中国提出的共建“一带一路”倡议。Yeah, I think so. That's like what post. Yeah, those are kids. The big. Yeah. Oh, we got all these out. Teorica contemporanea, società Wii. Amici ascoltatori, ascoltiamo ora insieme un piccolo brano tratto dal vocale. And the air comes like, no, you can't, no.
Наше применение принципа перспективы и проекции.
Medium wave band. For the medium and long wave bands, only the small internal ferrite antenna is used. Long wave band. The frequency counter appearing in this project was made using a ready-made module capable of measuring frequencies between 100 kHz and about 60 MHz, with the possibility of adding or subtracting an intermediate frequency value, operating with 2 programming push buttons. However, this frequency counter module requires a signal of a significant amplitude. Therefore, a preamplifier was built like this schematic diagram and plans show. However, for obtaining the most out of the 2 transistors, in place of the resistors R2 and R4, 2 multichurn trimmers of 200 kilo ohms were used and set to the point of maximum gain of the preamplifier.